Hello, everyone, and just like the Family Feud, Steve Harvey says we've got a good one for you today, and we have a good one for you today with 3D tiles. Today's webinar is going to be on 3D tiles and visualization advancements in 11.6, and I'm your host, Craig. So we also have Alex Wood, an advisory software developer at AGI, and to his left, which it doesn't make any sense to anyone listening live, is Ed Mackey, and he's also an advisory software developer. Before I hand everything off to those two, I just want to remind everyone that we do encourage questions. And if you have a question on something that they taught, we'll answer them at the end of the webinar, but you can ask that using the questions panel in GoToWebinar. So somewhere on your screen, you should see the questions panel. Just type in your question in that panel, and then we'll see it on my screen, and I'll make sure to answer or ask the question of Ed and Alex at the end. Okay, without further ado, Alex, it's all yours.
Thanks, Craig. So Alex Wood, Ed Mackey here. We're both members of the STK 3D graphics team, and we're really excited to talk about one of our headline features in STK 11.6, and that's 3D tiles. And before we get into 3D tiles, we'll cover some of the visualization improvements that we made with glTF, which is actually closely related to 3D tiles. So we'll get moving right along here. So in STK 11.5, we introduced glTF to STK, and it's a drop-in replacement for MDL and CAD Models. So you'll add it to your STK objects in the exact same way that you did before. But with it, it puts STK in line with this PBR, this physically based rendering renaissance that's coming out of the 3D graphics industry. Here's just a nice example. I saw this last week from the Analytical Graphics Twitter account promoting the webinar that's next Tuesday. And here we see an STK scenario that's just showcased with a glTF launch vehicle. So you can see some beautiful materials, and we'll get into a little bit more about what goes into these glTF models. So we'll hopefully, at the end of this webinar, we'll demystify a little bit about glTF, physically based rendering, and 3D tiles and how we handle those. So what happens, though, if you need to render more than just a model of a satellite? In this case right here, we're looking at 1.1 million buildings, and you can't possibly expect to render that as a single model, nor can you expect an engineer or artist to painstakingly georeference all those buildings or city blocks in an SDK scenario every time you pull up a new or create a new scenario. This data set was a city GML data set that was curated by the Department of Information Technology and Telecom, and it was processed into a 3D tile set. So that's a little taste of what we're going to cover today, and we'll dive right into it, and that starts with glTF. So you might hear us, so what is glTF 2.0? So glTF, it's a runtime format for 3D models, and it's optimized for efficient transmission and loading. And what that means is, when you hear runtime format, what we mean by that is it's designed from the ground up to get that geometry and materials from disk to GPU as quickly as possible. And when we say 2.0, we're discriminating against glTF 1.0. So 2.0 brings physically based rendering. And what they did when they took that step to 2.0 is 1.0 was very closely tied to WebGL, and models often embedded the shading language that's used by WebGL 1.0, and 2.0 is it's graphics API agnostic. And so instead what they do is they said, all right, we need a new way to describe our materials, and that's with physically based rendering. And we had, as soon as that it started out as an extension for glTF 1.0, and then it got some major backing by big players such as Microsoft and Google, and just all of this momentum behind there. And that's what really led to push for the glTF 2.0 specification. And just one last thing to mention, when you hear physically based rendering, it's not, as it says on the slide here, it's not so much about emulating physics. It's more about the physical properties of real-world materials. And so in the case of the core glTF specification, that's how metal or how rough. Those are the two core parameters that make up these materials. And rather than just show you pictures of this, I thought it'd be good to kind of step out of the presentation and have a little demonstration here. So I'm going to pull up Visual Studio Code, and I have a glTF model here. This is let's render this. So this is the collada duck, and one of the first models, sample models that was provided to glTF. And on the left here, this is the actual contents of the glTF file. It just looks like JSON. It's very approachable, but all the assets are out of this file. The textures are out, and there's images that are all referenced here. There's a binary that is where all the geometry is. But most importantly, right, we have these materials. How does this duck look? And right now, it's not metal at all, and it's not rough at all. And so, just to show you, this is again the whole intent of this is just to give you a little bit of a brief introduction as to like what PBR is and what it can do for us. So, let's say rather than the default value roughness of 100% rough, if we made that, we want a shiny duck. And so if you just drill that down to 0 and save, we get immediate feedback here. You can see how just that one knob, that one artistic knob that we have, can just change the look and feel of that particular model. Now, I don't know how well that you can see that on the GoToMeetings or on the video here. So let's play with a more dramatic parameter here, and we'll take that metallic factor and we'll put it up to 100%. So here's a full metal duck here, and you can see now that there's this environment that's kind of reflected back. It's a perfect mirror surface. And just to show, these values are not just a 0 or 1 setting here. If we just kind of start to slowly walk up that roughness factor, you can see that reflection blurs out a little bit. We'll go a little bit more. Now it looks like a duck ornament. So now while I'm playing with parameters that affect the whole model here, this physically based rendering, it's typically an artist will almost paint these properties on and intermix them. So you'll kind of have this transition of roughness and this transition of metallic. So it really, just with these simple knobs here, it gives a more compelling way to describe and author your materials. And by using these properties, any platform can come up with their implementation that most efficiently renders these materials. So that was an important reason for us as a desktop product SDK to really adopt the glTF 2.0 specification. So back into presentation. So while glTF 2.0, it's maintained by the Kronos group, who are the same maintainers of OpenGL, Vulkan, WebGL. It's in Collada, just to name a few. It has a very wide reach in the 3D graphics industry. So here's just a little chart of a bunch of companies that have all have been major backers of the glTF 2.0 specification. And you see AGI is listed here too. Our own Ed Mackey here, he's actually on the glTF working group. Is that correct?
On the 3D formats working group within Kronos, yes.
Perfect. All right. So, yeah, we've certainly, as we've gone through the implementation, we've had our hands in glTF for quite some time. And it's not just in Cesium or STK, it's everywhere. If you open up Facebook, you can drop a model into your Facebook feed. And actually, Ed, I just found out from you yesterday, you can orient your phone and it will, you can inspect the models.
It adjusts the position of the model as you move your phone around.
Yeah, that's very cool. So, I mean, it's really making out to the masses, to the mainstream. It's even in the latest versions of Microsoft PowerPoint. Minecraft, actually, you can export a glTF model, and we have seen Minecraft models in SDK, which is really just what drove the development of this, so we could see our Minecraft models. But in all seriousness, it's what the real benefit for AGI is. It's also the core model format for Cesium, and what that means for us is interchange of visualization between our products like SDK and any sort of Cesium application. So and on top of that, the 3D tiles specification uses glTF as its primary payload, and we'll get into that in a little bit more. And Should also point out this book at the bottom here. Just earlier, it's like 2 weeks ago, or a couple weeks ago, this book came out, and there's a whole chapter dedicated to getting glTF, getting up and running with glTF, and so it's just really at the front of our industry in terms of modeling formats, and there's a lot of just benefits to using this for real-time graphics, and so it's we're excited that this is something that we get into our that's in STK and available now today. So just a little example of the interoperability. We have a simple scenario shown in STK, your typical satellite and access to a ground station. And using the CZML export tool, the CZML export plugin to STK, you can export that visualization into a CZML file and drop that into a Cesium viewer. And here we can see the exact same model asset, 3D model asset, is shared between both of them. So it's great in terms of interoperability to have that consistent visualization across products. As I mentioned, it was added in glTF was added to STK in 11.5, and when I say drop-in replacement, I just wanted to kind of highlight a few things here. In order to get glTF into STK, we registered 2 extensions with the Kronos group, with the glTF working group, 3D Models working group. So these are public open specifications on how we define things like articulations, attach points, model pointing, and in a separate extension, we have a lot of the closer to STK analytical pieces, such as solar panel annotations and obscuration. So a glTF model with the right markup will work in the solar panel tool, work for obscuration, just feature parity with how we had model support with Collada and MDL. And this also lists. We talked a little bit about metalness and roughness, and just to quickly go over some of the other parameters that you might see in a physically based rendering material for glTF. You'll see normal mapping, where you can define scratches and bumps and little micro disturbances on the surface. And then we also have ambient occlusion, which is that self-shadowing effect, and really just adds some nice contrast and richness to your models. And then emissiveness is a way of defining light-emitting parts of the model. But 11.6, we took another pass at our lighting model. So if you're using 11.5, I'd encourage you to upgrade to 11.6 just to get those lighting improvements. I'm a big fan of those. And what you'll see is the lighting is more responsive to custom lights like the flashlights or any custom lights that are added to your scenario. And you'll see richer contrast from those ambient light sources or the sun. And you can kind of see that flipping back and forth in the upper right there. The differences between the two are pretty, I think pretty significant. Now, I say 3D tiles for those. We added support for 3D tiles in 11.6, but before doing that, we had to add support for some glTF extensions. So as I mentioned, glTF, that's the primary payload on 3D tiles. And there's a lot of data, like if you had massive photogrammetry models, they will oftentimes be using the unlit material, and that is just, it's used because photogrammetry will have lighting information, the shadows, all that's already baked into the photogrammetry capture. And unlit is just informing the model, just bypass all your lighting calculations. Lighting's already in the textures, and it's actually a fast path, so it's nice to have. Now, Draco compression is important just even outside of 3D tiles. It's a mechanism for compressing your 3D meshes, and it was developed by Google. And what that'll do, the reason why that's important for massive models in 3D tiles is because if you have these massive models, you want them to take up as little space as possible, or less space on your storage device. And you also want to have a smaller footprint when you're sending those, streaming those down to your users. And so, whether you're maybe hosting your 3D tile sets out of Azure, AWS, there's a cost to how much information you're sending down the pipe. So it's always good to have Draco compression there just to keep that efficient small footprint. And finally, we added specular glossiness material. And that is not related to 3D tiles per se, but PBR has been around for a while, and there are different material models, metallic roughness being a very common one, and that's part of core glTF. But then specular glossiness is also pretty popular out there from the content creators. And so as an extension to glTF 2.0, they define the specular glossiness material, where you're defining more of like how the lights interact with the lighting properties interact with the model material. So the diffuse, specular, and gloss channels are how those materials are configured. And you can kind of see that in this image in the lower right, how that's broken down. And actually, we'll jump out of the slides again and take a look at adding, just to show how we add glTF to, we'll do a little interactive session here with STK. So we'll go ahead and create a new scenario. And what we're going to do is I promise Ed here actually talked me out of adding the duct to a satellite. I think it would have been a first for our webinars. And we'll...
Yeah, that would have been our first.
Yeah. Okay. There's still time.
Missed opportunity.
There's still time. Instead, actually, we'll go to... all right, let me add the satellite first. And then we'll go out to Sketchfab's, a place I like to go for 3D models. I'm not endorsed by them. But I'm going to put a satellite here. And we'll go to Sketchfab. We'll look for another satellite model to put on our... So let me just close him out. Okay. So before we go off...
Let's see that glorious default satellite model first.
My favorite satellite, the default satellite. Right, so out of the box, actually, you can see nice foil material on the model. This is using our default reflection environment. We should talk about that in just a moment. Let's get the new satellite in first, I think.
Okay.
All right. Let's go to Sketchfab. And let's find a satellite. And we'll get a downloadable satellite. They have it's also a place for any 3D modeler to show off all their works, and so you do want to look for downloadable. And here's a free one right here. And because this is glTF, we'll be able to see this model rendered in the browser, interact, look around, and make sure this is the model we like. And I like this. So what you'll do is you'll just go down here and download the model. I like this model so much, I actually pre-downloaded it.
Oh, what were the odds of that?
Yeah. And we'll go ahead and add this to this satellite. We'll replace our model here. And the way you do that is, as always, you're going to go down to the 3D graphics model panel. And here you see our default model is satellite.glb, and we're going to go to that location where we downloaded this, and it was downloaded as scene.gltf. I'll just open that, apply, and there you have it. So that same model rendered in STK. Well,
slow mouse movements for WebEx.
Yes, I apologize.
For GoToWebinar, I'm sorry.
And okay, so just if I could go back to that reflection environment thing. Let me add another satellite. We'll go back to the default satellite.
You're going to put that one in a different orbit?
I think we should put that in a different orbit.
I think you should.
I'm going to put that up just a little bit. Okay. Okay, so if we go back to the model properties, I'll tile vertically here.
Yes, please.
We can look at the properties on the model. So you notice this is a new section in 11.5, and it talks about how the reflection environment, like what reflection environment we're using. Now, this default procedural reflection environment it's procedural because we have this, it's all processed on the GPU, and it's this notional ground, this notional horizon, this notional sky. So when you're on the ground, you see the blue sky. And at nighttime, actually, stars come out, and they're oriented with, you get this nice Milky Way band that follows the stars because STK wants their stars in the right orientation. But as that model increases in altitude, actually the sky drops out and the stars are revealed as we leave the atmosphere. So that's all procedural. It's all calculated on the GPU. So there's no actual imagery. But then there's this notion of image-based. I'll actually go to HDR Haven. So HDR images. HDRI. Okay. So just to show you what we mean by these image-based reflection environments.
It stands for high dynamic range image.
Yes.
And it is a reflection environment, usually captured from a camera.
Right. And the importance about high dynamic range, and we'll actually show this on the satellite, is the image also serves as a not only contributes that scene that we saw reflected in the duct, but it also contributes on the it serves as a light source. And so you can have lighting information that's coming from this direction, this part of the reflection environment, and shining lighting information on that model. And so I'm going to add this paper mill here to a satellite, because why not surround a satellite with a paper mill? And you can see right now with that paper mill environment, it looks a lot different. And the reason why is because there's all this contrast and detail and variance of light coming from the surroundings that it just brings another level of realism to your model.
Sure. The lighting environment in space is quite bizarre. There's darkness all around you, and then there's this weird blue glow from below, which is a very unnatural method of lighting for a human eye to be looking at. And so putting something like the paper mill environment or any of these other outdoor environments on your spacecraft can actually make the vehicle look much more natural to human viewers who are not accustomed to being astronauts and live their whole lives here on the ground. The only downside is if they zoom in a little too close to the satellite, you might see a tree branch or something reflected on one of the shinier panels, and then the gig is up. You can realize, wait, those are leaves I'm seeing in the reflection environment, and then people know that you've pulled some dirty tricks on them with the reflection environment. But as long as you keep the gold foil crinkly and you keep the camera a little further away, it can make the satellite look a lot more believable to have an Earth-based, an Earth surface type environment wrapped around it.
Yes. So long as it looks good.
Yes, whatever looks good.
Okay, so I guess we'll go back into the slides here. So I'm not going to add a duct today. All right. Yes. So one aside here. So we talked about, you might have noticed the default satellite's a satellite.glb. And then when we loaded the satellite downloaded from Sketchfab, that was a glTF file. So Ed, do you want to tell us about why the importance of GLB and where that came about?
The GLB, we often get the question, why didn't you just dump all these files in a zip file? Obviously, when you have a glTF, it doesn't work by itself. You have all these textures that go with it. You have a blob of binary, a .bin file that goes with it. That's all the mesh data. GLTF, one of the main targets for GLTF is mobile devices and WebGL, and we don't want JavaScript and low-powered devices to have the burden of having to extract from a zip file. So we have our own container format, the GLB, that's much more amenable to a website, or even JavaScript running inside a mobile browser on battery power can easily get these resources out of the GLB file and onto the mobile GPU very, very quickly. And while that may not be too meaningful directly to desktop SDK users, the point is you may want to then export that visualization to CZML or Cesium or to a mobile device, and the GLB becomes a very effective package for delivering that all as a single file rather than as is shown in the upper right, a folder with a bunch of files strewn around that if you share some of them but not all of them, that it won't work correctly. So it's much easier to deal with a single file and hand it off to a client or someone else much more easily as a single file.
Yeah. Now, this probably isn't the official stance, but the way I also see it is if you're iterating on the model a lot,
mm-hmm.
you'll want to keep it in the glTF format, like so that you can tune parameters, you can interact with that. And then when you're ready to distribute it, bundle it up
into GLB
right. File. So that's why all of our default models, they're already pre-bundled because we've done the iterations on them. And I'll also say that that Visual Studio Code Editor, it's free download. It's has an amazing plug in the glTF tools, and using that tool, you can easily interchange between glTF and you can kind of explode a GLB file into a glTF file like what we have up here, where all the textures in the bin file are all pulled out of that model, and you can get that readable glTF JSON. So, and you can go in both directions there.
Yes.
Okay. So, just moving right along here. We talked about, so now you know a little bit more about glTF and PBR, but let's talk about 3D tiles. And really, what we're looking to do is solve the problem of how do we deal with massive data sets, because not everything is that simple, or is a self-contained model that gets plopped down as a facility or put on a satellite. You might have massive data sets, and I'll think it's better to just pull up a scenario in STK and we can take a look at a 3D tile set in action. So we can close out of this. And so, another massive, we're looking at ways to handle massive geometry. And we've actually had to deal with this problem in the past quite a bit, and that was with terrain, right? Terrain geometry. And it's the same kind of, it's actually a similar solution, right? Because you have all of this terrain data, and you need to break it apart into lots of little tiles and have levels of detail on that, because when you're looking at the full globe, you don't want to have thousands of millions of polygons representing the Grand Canyon. It's just not necessary. And here, before we dive into that beautiful tile set, let's go to Half Dome real quick, and I'll just show you what. We get a little more context here into what we're talking about. So I'm going to bring up the 3 properties and tile vertically, because we'll toggle back and forth between.
Yeah, let's see it zoomed in and out without the wireframe.
Okay, sure. Right. So as we zoom out, so this is Half Dome. It's beautiful. There's a lot of geometry there to represent that. But as you zoom out, you'll see the imagery change, sure. And actually, I'm sorry, I'll go a little bit slower for those.
That's coming through.
Okay, great. And let's see what that looks like in wireframe real quick. Right. So we have a lot of geometry here. And as we zoom out, we'll take all these tiles here, we'll combine them, and we'll simplify them with less geometry. And repeat as we zoom out more. There's the same visual features are preserved as you're zooming out, but you're only showing the detail that's necessary to convey the underlying data from this point of view. Okay, and so I'd like you to keep that in mind when we look at the 3D tile set, because it's a similar concept, right? 3D tiles is just using a spatial data structure, that's that organization of that level of detail pyramid, and to break apart this model and show you only the features that are important close to the camera.
It's a fancy way of organizing the data such that stuff that's very close to the camera gets to be high res, and stuff that's off in the background can be low res. And that way you don't overwhelm your graphics hardware asking for an entire city full of high res models.
Right.
You can sort of cheat a little bit and just show the low res stuff in the distance.
Exactly. Right. And actually what we're looking at here, it's we're doing a little flyover of a photogrammetry tile set provided by, this was curated by Nearmap, and it's of Lower Manhattan. So we earlier flew past the World Trade Center, and we're closing in on the Empire State Building. And, if you pay attention to like the tops of the buildings, you can see as we get close, features like air conditioning units come into view on top, and it's pulling in the details when the camera gets close. But otherwise, it's we don't need all of that detail off in the distance. So the other thing that I did want to mention here, let's just pause here. So to add a 3D tile set, right, you have to in STK 11.6. We have it integrated into the Globe Manager, and if you want to play around with this with 11.6 right now, you can actually click on the plus button, add 3D tile sets, and installed we include a sample 3D tile set. So this is the AGI headquarters, and we can just add that right here.
Yeah, we ship that just as sort of an example of what 3D tiles is and what you can do with that. And one of our guys actually flew a drone. One of our guys from One Sky flew a drone around the campus here and captured all of the photographs for the photogrammetry. And then we tiled it up, I think, with, I think the photogrammetry was assembled in Pix4D or context capture or one of those. And then we ran it through our 3D tiles pipeline, and we came up with this tile set that you see on your screen before you.
That's correct. And it was, I think it was like 1 million polygons and just all sliced and diced into a nice performant tile set here. Now, actually, we just showed both these tile sets are actually hosted locally. So this is currently serverless environment, but we have we also have if you for hosted content, we have access to 11.6 was connected to the geospatial content server. So that's part of our enterprise data services, and I actually just happen to have my login right there. So we'll take a look. You know what? Before I add that, I want to go back to New York City, because I know that there's a city GML tile set there. Nope. Get back on that path. And
you're going to turn that tile set off.
Oh yeah, I'll turn that tile set off, and we'll actually replace that. We'll do that same fly through, but with the city GML tile set that we saw earlier.
Okay, your camera is off in space somewhere here.
Right there.
Go.
Okay.
Perfect.
So I'm going to go ahead and add this 3D tile set. And I took myself off there again. All right. Add 3D tile set. Hosted. I had already logged in, so we're good. I'm going to go to add the New York City.
This is the white buildings one?
Yes. Right. So this is all based off of city GML rather than the photogrammetry. So it's much more. It's
so the detail is more crisp, but we don't have any color information.
Yeah. That said, though, city GML does support texturing. So there's another tile set that's hosted on the GCS. That's Berlin. That is city GML and has the textures as well. But as you can see, it's just another another look at the New York City data set. And a little earlier, we kind of were curious. Should we see what this looks like with?
You want to see them overlap?
I really.
Alex loves to show this. Go ahead, show us.
We were just curious, and I thought, all right, well, what does it look like when we actually look at the photogrammetry and the?
We were curious how well the city GML lined up with the photogrammetry, and so you turn them both on at the same time, and the result is something that probably makes graphics programmers very excited when they see intersecting, overlapping polygons, and they think, wow, the registration is really great. And all the other non-3D graphics programmers out there are probably looking at the screen and thinking, that looks horrible.
Yeah, so don't try this at home, but
yes,
we're going to try it here.
Well, you guys are professionals, so that makes sense.
That's right.
Yes, we know what we're doing here.
That's right.
Okay. So I think that, let's go back to the slides here. So just to cover a few last points here. So massive 3D models, they often come in the form of photogrammetry, of city GML, also of CAD models. And something that's unique to STK, we added this in 11.6. If you had a CAD model, let's say one of your satellites or International Space Station, you can actually, through the connect command, add a tile set and put it in whatever reference frame you'd like, which means you could attach it to the body frame of a satellite, and it'll follow the satellite. It'll be in that system. So it's those level of detail will res in as it passes you and res out, and you'll go hit the lower level of detail as it drifts away from you. 3D tiles, it's important to note that 3D tiles is an OGC community standard. So it's got this standardization body behind that's behind this particular specification. And if you're curious, the specification is out on GitHub, and so you can look at it. You can see, go through it yourself, see all the capabilities that are there for this particular format. And lastly, it has been, just like glTF, it's been designed from the ground up with 3D in mind. So there's a lot of container formats out there that keep on, that are really built for 2D maps, and that's really common in GIS. And we have to kind of do some mental gymnastics to extrapolate what the 3D information is out of those data sets. This was built with 3D in mind, and so it's it's using also a whole set of spatial data structures, whichever is appropriate for the particular data set you're using. So things like rather than just dicing everything up and slicing through models in a city block, it might actually cut the models along the city streets rather than directly through a building. And so there's it really opens us up to when you split the model up like in that fashion, it actually makes the streaming the model pop in a little bit more accurately. And then I also say precision rendering, and that with each tile, all the tile data, all the content that comes along in this 3D tile set, we have things like the geometric error. So we know how much error is at this particular level of detail, and knowing where that piece of geometry is in the scene, we can figure out like whether or not we need to refine that and pull a higher level of detail in, or if we can, or if that's an acceptable, representation to show all the details that we need to show. As we said many times here, glTF is the primary payload, but there's also point clouds is another payload that you can find in 3D tiles, and instance geometry for things like all the bolts and trees and lampposts that are in your city GML. So there's really, it's just a fantastic format. Okay. Oh, I have another thing to show here is just a debug view on. I'll pause it right here of the 3D tile set. So when the viewer, just to show this hierarchy a little bit more. So when the viewer is far away, we're looking at a single model and a single tile. But as we approach the AGI headquarters here, new tiles are pulled in as the detail needs to be added, and you can see, you get a little visualization of all the different tiles that are, loaded in as the camera approaches the surface of this model.
So each yellow wireframe box represents a single tile from the 3D tile standard, and each one essentially contains a single glTF model of just that section of the photogrammetry space.
Yes.
Our air conditioning units have never looked better.
Yes, yeah. I feel like there should be more on there, though, on that roof.
Considering how often they fail, I agree.
Okay. So before we get kicked out of the building by management, right, property management, we should also comment that so our hosted 3D tiles. So we've seen the beautiful local tile sets, and we've seen the tile sets hosted in GCS. But you might be wondering, how do I get my data into a 3D tile set? And I just wanted to highlight some of the model. What you need to do is send your source data in through a tiling, the tiling pipeline, the 3D tiling pipeline, and that would be either through Cesium Ion or GCS, and which is our on-prem, the geospatial content server. That's the on-prem hosting and processing platform that STK 11.6 is currently hooked up to. When you send it and process it, they will produce 3D tile sets and host things like imagery, terrain, and 3D tile sets. And those can efficiently stream to any device, whether it be in Cesium or STK. And that's about the last thing there. And actually, back on that last slide, the one other thing I wanted to mention too is we do, STK does support the local tile sets and the hosted, and the local tile sets, they're really effective if you're the only engineer doing the 3D and you don't have to share the tile sets. But the hosting option really comes to shine when you are working on a team, when you have a bunch of developers you need to share, because again, when we're working with massive data sets, while we do try and keep that storage footprint low, as soon as terrain, someday terrain is going to be, I would predict would be in the 3D tile set specification. that's going to take up a big footprint, and likewise with these New York City photogrammetry models. And so having those out on a server, curating them once, and then just making them available to any of your Cesium or STK users, you'll want to do that with that server, the hosted option. So hopefully we've spent some time here to demystify glTF 2.0 and physically based rendering, and we talked a little bit about how you'll want to tile up your massive models and hopefully be using the 3D tiles specification. It's all of these that we've covered today, they're open standards. They're backed by standard organizations such as Kronos Group or OGC. And if you plan on using 3D tiles, we'd love to hear about it, your use cases and what sort of data sets you're working with. That helps us in terms of optimizing your experience in SDK. And likewise, if you have any experiences you'd like to share with us with glTF in 11.5 or 11.6, we'd love to hear it. Now, I guess we'll take some questions.
One of the questions was actually on the drone footage that was shown of the AGI headquarters, and they were wondering how the 3D tile pipeline, what was used to convert that drone footage. Do we know that, or do we have to ask OneSky?
I can attempt to answer that. Pix4D, whether or not Pix4D was used for that particular drone capture, I do know that's a pretty popular one. I've seen that used.
It was.
Yeah. Yeah. So they just did a pre-programmed flight around the AGI headquarters, captured a bunch of images, and with photogrammetry, you're just getting these different perspectives and using that information to extrapolate.
By a bunch, you mean thousands, I believe, right?
A bunch.
A bunch.
Yes, correct. Thousands of images, right, to extrapolate the 3D geometry from those images. And Pix4D is commonly used to just give you that massive model as the output. And then when you have that massive model, you can try and get that in as just a single model. But
right, you could take that model and load it directly into SDK as one model, but your performance would suffer a lot if you tile it up as 3D tiles. It will only load the parts that are closest to the camera in high res, and performance will be a whole lot better.
Yeah, what I like about 3D tiles too, just to tack one last thing onto that is, this level of detail thing is nothing new. Game industries, the game industry has been doing this for, decades, and SDK has been doing that as well, and most prominently in terrain. So, it's a great solution for addressing the performance.
Here we have one more question here. How well do the tiles work with terrain needed for something like UProp?
How well will the tiles work with terrain? Okay.
Yeah, like terrain that's needed for like UProp.
Okay, so terrain isn't today. Terrain is not in 3D tiles. If that's the correct question, or if I'm answering the question, if not, please you can let us know in chat. So terrain is actually separate from 3D tiles. We hope that we're coordinating to see how we can get that into the 3D tile specification, because it is such a good fit. But there's optimizations that are being discussed as far as how that is going to be represented in 3D tiles. So today, the way that they interact is, let's say you have buildings. In the 3D tiling pipeline, you'll actually reference a terrain tile set and say, hey, this is the floor of my like city GML. And it uses that terrain to when it's doing the processing of city GML, for example, it'll draw the skirts and actually drop those down to the terrain level. So it is informed by terrain, but today, I mean, it's the visualization component that's put on top of the terrain.
Okay, thanks.
Yeah.
I don't see any more questions that have come in, so if you go home tonight and you start thinking of other questions, please do not hesitate to email us at info@agi.com. We would love to answer those questions. And then we will connect you with the right engineer, which will probably be either Ed or Alex, to answer the questions. So again, that's info@agi.com. We also recorded this on video, and we'll put it up on our YouTube site, which is youtube.com/analyticalgraphics. And make sure you subscribe there, because all of our webinars and tech tips are all going up there. So please go there and subscribe to that. Also, Alex touched on this a little bit earlier, and that was that we're going to have an Apollo 11 recreated webinar next week. That will be on May 21st. And that's just the webinar to talk about the mission. And we have, I think, John Carrico is going to be in it, and then Austin's going to be doing it as well. And then we also have 3 trainings that we're going to teach you how they did the mission using STK, and they're going to be June 4th, 11th, and 19th. And you can sign up for those on our website at agi.com/training and then /events for the webinar. So again, we're going to take you through launch and into orbit around the moon, and then eventually touch down on the second one, and then out from the moon, and then back down to splash down on the third one. So we've got some great content ready for you for the 50th anniversary of Apollo 11. So stay tuned to our AGI Tweets Twitter account, and then on our website as well. So again, thanks for joining us. And if you have any more questions, email in at info@agi.com. Thanks for attending.
Thanks, everyone.
Thank you.